So we'll be talking about today about symmetric matrices, skew symmetric matrices, and its properties. So symmetric matrices are basically the matrix where the transpose of the matrix is the matrix itself. So I have an example for you. So for symmetric matrices, basically A transpose is equal to A. So that implies that this matrix which you are given A, H, G, H, B, F, then G, F, C. So this is basically an example of a symmetric matrix. And what happens in the case of a skew symmetric matrix? In skew symmetric matrix, basically the transpose of the matrix is given by the negative of the matrix A. So in that case, we have that the diagonal elements are all equal to 0, and basically if this is H, this is the A12 element, then the A21 element will be the negative of the A12 element and given by minus H, and that will go on, so on and so forth. So this is basically the examples associated with the symmetric matrix and the skew symmetric matrix. So now let us try to understand the various properties which are associated with these matrices. So suppose let us go into the first property. So the first property, let me denote it by property 1. So the property 1 basically states that all the diagonal elements of a skew symmetric matrix is 0, as I have already indicated over here. So the property 1 is very straight, easy to understand, that all diagonal elements of a skew symmetric matrix is equal to 0. Okay, so this is the first property. The second property that we'll be talking about is related to property 2. So property 2 says us that if we have a matrix A, basically A is a square matrix, then this matrix A can be written as the sum of two matrices P and Q, where P is a symmetric matrix and Q is a skew symmetric matrix. And this P can be written as half into A plus A transpose, which is a symmetric matrix, and Q can be equal to half into A minus A transpose, which is a skew symmetric matrix. So this is the property 2. So property 2 basically says that if we have a square matrix A, then that square matrix can be taken as the sum of two matrices, suppose P and Q, where P is a symmetric matrix and Q is a skew symmetric matrix. And in that case, P can be written as half into A plus A transpose, and Q can be written as half into A minus A transpose. So this is the property 2. The next property that we'll be talking about is the property 3. So in property 3, basically we get to know that suppose A is a square matrix. We take a square matrix again, that A is a square matrix. Okay, so A is a square matrix. So if A is a square matrix, then we have the matrices A into A transpose and also the matrix A transpose A. Okay, so these are the matrices that we get. And then these two matrices, A into A transpose and A transpose A, both of these matrices are symmetric. So this is the third property. Basically, we have the two matrices A transpose A and A transpose. If A is a square matrix, then these two matrices are symmetric. So this is the third property. So now let's get on to the next property, which will be basically property 4. So let me rub it out so that I can get more space and we can complete it at one go over here. So let me rub it out. So the next we'll be talking about property 4. So this is the next property that we'll be talking about. Now this says that suppose we have two matrices A and B, and these two matrices are square matrices. Okay, so A and B are two square matrices, then the product of this matrices, then AB is also, we are not just concerned with square matrices, basically we'll take that these are symmetric matrices also. A and B are symmetric matrices also. So in that case, their product AB is also a symmetric matrix, if and only if AB is equal to BA. So if we have two matrices A and B, which are square matrices and also symmetric, then in that case their product is also symmetric matrix if and only if AB is equal to BA. This is the property 5. And the next property will be property 5, is that suppose we have the matrix A. So now A is basically, we can say A is a symmetric square matrix. A is a symmetric square matrix. So now if we take any power of n, suppose we take a to the power n, then where n is basically a positive integral number, so in that case, or positive integral number, so in that case that matrix will be also a symmetric matrix. Basically we'll say that then an is also a symmetric square matrix where n is a positive integer. Okay, so this is the definition. Why is it so? Because we know that because if we take the transpose of a matrix A to the power n, then this is given by the nth power of A transpose. Because this condition, if we apply this condition over here, then we can see that if we have a positive integral number, then if A is raised to that number, then that is also a symmetric square matrix. So this is basically this property 5. Now in this case we consider that A is a symmetric square matrix. So what happens if A is a skew symmetric matrix? So what happens in that case? So in that case we will see that basically if n is odd, if n is positive, so there will be two cases. Either an will be skew symmetric, or an will be symmetric. There are two conditions. So when is an skew symmetric? Now an is skew symmetric if n is a positive odd integer. So if n is a positive and odd integer, in that case an will be equal to skew symmetric matrix provided A is skew symmetric, and an will be symmetric if n is a positive odd integer. And why is the reason? If you ask the reason behind that, the reason is same as this one, where we wrote that the transpose of an is equal to the nth power of A transpose. So this condition, because of this condition, we get that if A is a skew symmetric matrix, then an gives us a skew symmetric matrix if n is a positive odd integer, and an gives us a symmetric matrix if n is a positive, I wrote odd over here, it's not odd, rather even, positive even integer. So these are the various properties which are associated with the symmetric matrix and the skew symmetric matrix, and an understanding of these properties will help you in solving many problems which are basically dealing with the skew symmetric and the symmetric matrices. So try to solve as much problems as much possible from your books or whatever study material that you have, and in case you face any trouble regarding solving those problems, then you can comment in the comment section below and we'll try to help you as much as possible. So thank you for watching this video. We'll see you in a later video as soon as possible. Bye bye.